Hello everyone, welcome back to another episode of my Intro to UE4 tutorial series. In this episode we're going to take a look at blueprints for the very first time and work on creating our very first system or mechanic, and that'll be sprinting. So, as you may notice, I have added a little bit more to the level as a way of helping us get a good standing and when we're going to start testing our sprinting functionality. All I've done was add two platforms or two cubes and place a light above them both. To show you what it looks like in gameplay, the first one can be easily jumped to using the standard functionality. The second one, you can't. What we want to do is we want to make it so you can sprint jump across that gap to get to this one. Okay, so to do that, let's take a look at blueprints. So, navigating to your first person blueprint folder, and then into the blueprints folder, you'll find some assets you may have never seen before. On the very far left, we'll see something called the first person character. Double click this. Okay, now you'll see your very first look at blueprints, essentially. This is the blueprint for your entire character currently. So this controls the jumping, this controls the shooting, and this controls the movement. If you zoom out, you'll see a lot of stuff on the screen, and I know this may be intimidating at first, but don't worry about it. We'll get into it. So to really briefly go over what you're looking at currently, this is a blueprint interface, as denoted by the big blueprint text right here. It's broken into a few interface components. Let's take a look at those. As before, the very top bar we have are kind of our project tools. These things you won't really need to touch very much, but it's closely resembles what you saw before. On the left, you'll see the components tab. This is all the components that comprises a blueprint. And you can kind of think of a blueprint as an object, a class as you would. So for example, a character, a human, he may have his body, what we refer to as mesh or a geo. He may have a gun, which is attached to his hand. He may have shoes that attach to his feet. All of these components go together to form a character. And this will show you what they all look like. Below that, you'll have your blueprint overview. This contains your other graphs, this contains your functions, all your variables, and information that can be stored and used later on. To what all these means, if you're not familiar with them, we'll be using them pretty quickly. On the right side, you'll see your details panel. This details panel will appear and change differently depending on which component you have selected. As we noticed in the world when we selected our cubes, we got the details panel for the object that we had selected. It's the same thing here, just details and properties relating to what we have selected currently. So, and then in the very center, you have your viewport or your event graph. This is all your blueprints laid out on a 2D space. Blueprints are a visual scripting language. Everything's based in nodes, and between those nodes are wires. And these wires are essentially telling the code, here, this is where the code's coming from and where it's going. For now, a lot of this looks intimidating, but actually a lot of this we can delete. To note, and a special mention, Unreal does set up its templates with full virtual reality functionality, but this also adds a ton of extra code we don't need. So let's take a moment to clean this up, get rid of a bunch of stuff before we start on our sprinting. Okay, let's zoom in first on movement input. Taking a look at this, this doesn't look that bad. One thing we do want to get rid of though is, actually I guess this can stay the way it is. So movement input, that's good. We don't need to touch it. Zooming in here, reset VR orientation, go ahead and delete this entire box. Okay, going left, blah, 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 blah. This is pretty much all based on VR. So we can just go ahead and delete everything except for the event gameplay. And you can also delete the comment box right here. Okay, going down, the spawn projectile. This has a lot of stuff relating to it. We can just leave this for now. However, one thing we do want to delete is, actually it looks like we can kind of leave this here for now. Okay, good. We can kind of ignore at least some of that. Okay, we've cleaned it up a little bit. There's some code that's missing now. To kind of break it down, I want to zoom in on one particular thing. Let's go into something that's easily understandable, the jump function. To quickly go over what you're looking at, you'll see everything's color coordinated by things like blue, there's red, some are green. This notes kind of what the node is supposed to do. So this is a node. The node type, denoted by red, in this kind of fashion, this is an action, or this is an event. An event is essentially something that is activated based on something happening. For example, this is an input action event. What this means is that when I press a certain key, whatever key is associated with this jump name, it will perform one of these two. And then from here, I can execute the code that is attached to it. And every event can be different. For example, this one's also an input action, but it's fire. Whatever fire is in terms of input, it'll execute all this. And there's hundreds and there's dozens and there's many, many events to be found. These are just examples. And what it's doing is it's calling this node called jump. I can tell you right now that jump is not just a single node. There's a lot of code underneath it. But for the surface level and for us, all we care about is that the jump function will make the character jump. Okay, that's pretty simple. Let's contextualize things. Let's get into learning blueprints in terms of the shift or the sprinting. So what I want to do is I want to make my very first event node. I want to be able to say, when I press shift, I'm going to start sprinting. Okay, let's look at that. I'm going to right click here. And you're going to get a big filter tab or big list and full of categories. These are where you can go and create your code and where all the code's stored. So anything that you can find relating to blueprints can be found in here. What I want to do is I want to look for an event for shift. So let's look up shift. And we see right here, there's keyboard events and there's left and right shift. Let's go with left shift for now. Okay, cool. We have our very first event. What we want to do is we want to, for now, let's see if this works. Let's just see if our shift button does anything. So to actually hook up nodes, what we can do is we can hover over these pins, as they're called, click it and drag it. This will allow us to, when we release, create a new node. Let's look for something called print string. What print string does is it'll print something of our choosing, some kind of message, to the screen. And this allows us on a debug level to kind of start printing values and information to the screen. It won't be intended for final production, but it's just intended for us to understand if what's going to happen happens. So for now, we're just going to hook pressed up to it. And so whenever left shift is pressed, it's going to print hello. Let's try that. Let's compile. Compiling is basically pick up the changes and make note of them. So if I did a bunch of stuff in here and never hit compile, it won't know that it did anything. So compiling will just say update. And then let's bring this down and click play. So nothing so far. I'm going to press shift. And there on the top left is a couple hello messages. Perfect. We know our event works. So going back to it, let's take a look at how do we make the player move faster. That's essentially what we want to do, is we want to make the player move faster. So looking at components, there's an important thing to make note of. The structure and how components or how blueprints function. When I made this blueprint, what I did is I made its parent, something that's inheriting from, if you can actually view that at the very top right, of character. The parent to this blueprint is the character class. What this means is the character class is like a template. It has all kinds of functionality, all kinds of values, all kinds of traits. And anything that's a child of it, in this case our blueprint, will inherit those values. So I can have 100 different blueprints all inheriting from the character class, which means they'll all have the base traits of the character class, but we can also additionally make unique traits for each of them. That's essentially how it works. One of the things that the character class granted us, if you look over here, is a character movement. This is a component that retains a bunch of variables and a bunch of properties relating to the physical movement of the character. So if you click it, in the detail panels, we'll get a massive list of all kinds of settings. The movement of the character are based on these settings, so we want to play with them. In terms of movement, there's one particular property that controls how fast we walk, and that is right here under the character movement walking tab, and it's called max walk speed. You can hover over it and I'll give you a bit of information. We want to increase this. Let's say we want to double it. So how do we do that? So let's get into the concept of casting and pulling properties from components. So we know for a fact this component has a value in it called max walk speed. How do we get that? One thing we can do is going up here, let's left click and drag. This will create a node that looks like this, like a little elongated pill. This shape is denoting that it's a get type. What this means is it's getting something from something. In this case, this is a reference. This is a reference to this component. What this means is we can now, using this, get information from it. And what we want to get is that max walk speed value. So clicking on the pin, dragging out, let's look up max walk speed. And we'll know that there's 4 we can choose from, 2 different sets and 2 different gets. We want to get max walk speed. Actually, we don't want to get it, we want to set it. So we want to click this one, set max walk speed, drag this up, or you can move it wherever you like, it's totally up to you. And we'll get a new type of node called a set node. You'll notice that now there's pins on the left side and the right side. What this means is that this is what we call an input. When this goes to perform the code that it does, in this case it'll say, make this variable or value called max walk speed, give it this value. The right side is a return value or an output value. What this means is after doing everything inside of it, it can return information. In this case, whatever walk speed is after resetting it, it will return that value and we can use it later. You may not see the immediate use case for it yet, but we'll look at it in the future. Okay, let's hook things up. So let's go up to our print string, and we don't need it anymore because this was just for testing. What we can do is we can disable this pin or this wire. To do that, we have 2 ways of handling it. One, you can right click this pin and do break link to left shift. Or you can hold down Alt and left click it. That is the fast way of doing it. Okay, excellent. Let's move this out of the way. And let's move this up to it. Let's hook up our pressed and our sets together. These pins are called execution pins. And let's move our character movement reference up a bit closer. Now there's one visible flaw right now, is that we're setting the max walking speed to 0. We actually want to set it to double what it currently is. Okay, what we can do is a little bit of basic math. What we did before, let's go grab the character reference again from the pin. Find get max walk speed. Oops. And we're going to do a get this time. And now we're actually going to say get the current max walk speed. And what I want to do is I want to times this by 2. In programming, if you're not familiar with it, the time symbol is actually the asterisk symbol. So we can do that. And what we want to look for is what we call a float. A float, if you haven't caught on already, are the green pins. The green pins refer to the float type. And to take a brief moment to look at that, data types are essentially the way variables are constructed. They're the type of data that variables hold. And they're all separated. There's always a variable type for some sort of information. There's no ambiguous type of data that any variable can hold. It's usually restricted to the type of data it supports. What I mean by this. So over here, these are our variables. These are variables or containers that we can put particular information into. Each one can only hold particular types of information though. It's not just universal. So what I mean by that is when I click, let's say base turn rate. Base turn rate is a float. A float number is a decimal number. As we see here, the default value is 45.0. But if I click on gun offset, we see 3 values, x, y, and z. This is what's referred to as a vector type. A vector variable is 3 values. If you click on using motion controllers, that's a boolean. A boolean is a true or false. Every data type is unique to itself. It holds different information. In this case, we're doing float information. So whenever you're hearing float or see the color green in this case, know that it's a decimal number. Okay, a bit of a tangent, but that's good information to have. So what's happening right now, let's get back to it. Taking the max walk speed that the player currently has, we're going to put it into this times node, and we're going to say times it by 2.0. I get a decimal number. And what's going to happen is that it's going to return, on the right side as we mentioned earlier, whatever walk speed is times 2. And what we can do is take this and plug this into max walk speed. And now logically it's saying get the current max walk speed, times it by 2, and set it to that. Let's try that. Let's compile. Let's drag this down and let's play. So when I walk forward and shift, I get really fast. However, there's a problem. If I keep doing this, keep pressing shift, my walk speed is forever increasing each time because I'm not resetting it when I let go. What I want to do is when I let go of shift, to reset my walk speed back. I'm not holding down sprint anymore. Okay, so let's make room for this. Let's take all of this and drag this up. Now I want to make use of this second execution path called release. And as you can probably assume, this happens when I release the left shift key. So what I can do is I can take this, copy and paste, plug release into this. And now we got to determine how we're going to get back to the original value. What we can do, this may not always be the best case, but we can do, is take this, delete it. Now we're going to look up float divided by float. So float in programming divided, or really in any case, it's always that. And we're going to do the exact same thing we did here, but using division. So what you imagine is takes the number, doubles it, and when we're done, divides it back. Let's see how that works. It seems to work okay enough. We sprint fast, we slow down. Okay. The danger of this though is we never want to rely on using a mathematical equation to get back to original value. What would be nice if we just always remembered the original value. That'd be great, wouldn't it? Okay, let's try something else. What we can do is we can actually say at the beginning of the game, retain the walk speed, like know what it is. Keep that in memory, and then all we can do is say, when we go to initialize it, take the base value, add to it, and then what we can do is, when we release it, just set it to that base value, instead of having to kind of work backwards. This will make use of variables. So let's go to variables tab on the bottom left. I want to click this little button in the corner. It only pops up when you hover over the tab. Click it, and it's going to give us an option. I want to call this base sprint speed. Okay. And it's actually the type red right now, which we can denote if you hover over it as Boolean. We don't want that. We don't want it to be a true or false. We want it to be the type float. So in the details panel, let's click on variable type, and you'll see a big list, and it gets a lot longer. Right now we don't need to dig into it. Let's go and click on the float type. We can click compile so that the default value appears, and now we can actually set the default value. What we can do is we want to match it up to whatever the game gave us. So going to the character movement tab, looking down to wherever that max walk speed variable is, it starts at 600. We want to keep that value and set our variable to match it. Let's go into base sprint speed. We're going to click that and set the default value to 600. Awesome, great, that's perfect. And let's try something. Let's say when I hold down sprint, I want to add a certain value to it. I don't necessarily want to double it. Okay, that's easy. Let's make another variable. Let's say base or sprint speed increase. And this is going to be set to, let's say, we don't necessarily want to double the speed. We want to just add to it. So let's say we're going to go to 400. So it's going to go from 600 to 1,000 when you're sprinting. What we can do is that we can change up our formula a little bit. Let's drag this in. So left click, drag it in. And we have an option between get and set. For now, let's just do get. What we want to do is we want to say, let's delete this times. We want to take current walk speed, add this to it, and then whatever that outcome is, make that the walk speed. So we always know the original speed. Perfect. Let's actually, because now we own our own copy of the max walk speed, we can take this out too. Another way of getting or setting is to drag this out in a different way. If you hold down Control and left click drag, this will automatically do a get on it. If you do Alt click and drag, this will do the set version. Just more hotkeys to remember. But we can get rid of this one. What we can do is we want to add it together. So we want to look up float plus float. And what we want to do is we want to say, using base sprint speed, add sprint speed increase, and then whatever this is, set max block speed to that. And there we go, our formula is much simpler, and we can just go ahead and delete this. That's awesome, isn't it? It's much cleaner. And now, let's say if we wanted to go back to the base walk speed when we're done, instead of going through all this, we can copy and paste this, bring this down. Oops, make a bit more room for ourselves. Like so. And we can just do, in fact, we don't even need the sprint increase. We can just go ahead and delete that, delete this, and we can just say set the walk speed back to the base. Like that. So this is very simple. Now, if we click compile, go to play, we can now sprint, and it'll always work. So let's see if this sprint system fulfills the near requirement for our gap. We can sprint, jump, I can make it. But if I don't use it, I can't. We've successfully made a challenge dependent on a system that we've just invented or just built. If you're ever confused in the future, and as the last kind of finishing off point, let's say you may forget what this does in the future. There's two ways to leave comments for yourself as a way of reminding yourself what it does. One, if you right click this node, on the very bottom there's a node comment. So we can say, let's say increases sprint speed by sprint speed increase. And now we have a little bit of a hovering comment. You can do this for every node. Or if you want to just give a big generalist comment for this entire area, select it over and press C. This creates a comment box. The comment box is nice because if you zoom out, it always appears in big letters. So you always know what each kind of sector does on your blueprint grid. Awesome. So in this video we went over events, input events particularly, and we created our very first system, which is a sprinting system. We were introduced to variables, variable types, and then using those variables to build a mechanic that allows us to design our level around. And now we have a level that's contingent on us having that system, which is fantastic. So now we can, next episode, take it even further and see what else we can do with it. Thank you for joining me.